T is called unbiased estimator of a parameter of a parameter theta if, so like suppose you want to estimate the theta value. Theta is related to population. Parameter means anything which is related to population. So if you want to estimate theta with the help of T estimator, then when you will say this T is a unbiased estimator for this parameter theta, the answer is if you find the expected value of this T and this will be same as theta, okay, then we say that T is unbiased estimator of theta. Okay. So when we say T is an unbiased estimator of a parameter theta, if expected value of T is same as the value of the parameter theta. So let me give you an example, then you will understand better. The example I have already given you. So first example is sample mean is unbiased estimator of population mean mu. Okay. Now I am going to show you that if we use a sample mean to estimate the population mean, then the sample mean is unbiased estimator. So it is very easy, students. Don't get worry about this. Okay, so I have already shown you earlier also, but now I am repeating it again. First of all, what is the meaning of sample mean? So if x1, x2, xn are sample values, the mean will be x1 plus x2 plus xn divided by n. So this we are calling the estimator. So this we are calling T. Now when this will be unbiased estimator of mu, okay, if E of x bar or E of t, this will be equal to mu. Okay, so what is theta here? Theta is mu. Let me try to make some analogy. So here we want to estimate population mean mu. In theta is not any parameter. Like if we are talking about mean, then theta is mean. If it is standard deviation, then it is standard deviation. If it is variance, then it is variance. Now, so this we have to show that if we find the uh, average of expected value of x bar, then it will be equal to mu. It means x bar is unbiased estimator of mu. This is the meaning of unbiasedness. Unbiased means if you find the expected value, if you find the average value, that should be same as the value of the parameter. Any doubt in this, students? And I have already shown you in the starting of the lecture today. See here that if you find the expected value of x bar, that will be equal to mean mu. So it means x bar is unbiased parameter of mu, an unbiased estimator of mu. So I am not going to repeat it. If you find the expected value, you take the expectation both sides, you will get it same as mu. So we have done it in the beginning. So any doubt, students? So sample mean is unbiased estimator of population mean. So let us do a second example. Example number 2. The second example is this. You can see on your screen. So if x1, x2, xn is a random sample from the normal population, with the normal population where mean of the normal population is mu and standard deviation is 1. This is a symbol for the normal distribution. First represent mean, second represent the standard deviation. This I have not told you. Like if we are given this kind of thing, n mu comma 1, it means mean is mu and standard deviation is 1. Okay. Now show that t is equal to this is an unbiased estimator of mu square plus. Show that 1 upon n summation I varying from 1 to 1 xi square is an unbiased estimator of mu square plus 1. So this we have to show. So what is the meaning of unbiasedness? It will be unbiased if I find the expectation of this, and this will comes out to be equal to mu square plus 1. So because we want to estimate mu square plus 1 with the help of this t. So that is why it will be unbiased. If you find the expectation of this, then this should be equal to the parameter mu square plus 1. This is the meaning of unbiasedness. You can see here. Unbiased means the expected value of t should be equal to the parameter value. Okay, any doubt, students? So I will show that if I find expected value of this t, it will comes out to be mu square plus 1. Okay. Now in place of t, we are going to put this. So what is t? So this we have to show. Okay, to show this thing. Now I will take the left hand side. I will find E of t. E of t is 1 by n sum of I varying from 1 to n xi square. We will apply the properties of expectation. This 1 by n is constant. It will come out 1 by n expectation of summation of these. So what we can do? We can take the expectation of individual expectation of xi square. I varying from 1 to n. Any doubt in this, students? So let us call this as equation number 1. So we have not used any of the information provided in the question till now. Yeah, we just want to show that E of t is equal to mu square plus 1. We want to show that this t is unbiased estimate of mu square plus 1. So we'll show expectation of t is equal to mu square plus 1. Now I am finding expectation of t, and when I apply the properties of expectation, I got this thing. Now I will, what we are given? We are given mean is mu and variance is 1. Variance of xi is 1. So variance of xi is equal to 1, given in the question. Standard deviation is 1, so variance is also 1. Okay. Any doubt? Now what is the formula for variance? The formula for variance is E of xi square minus E of xi whole square. This is equal to 1. Okay. Now E of xi square I need in the equation number 1. E of xi square I need here, right? So let us find the value of E of xi square. E of xi square, this is equal to 1 plus E of xi whole square, which is equal to 1 plus. Now what is E of xi? You are given that this x1, x2, xn is a random sample from the normal population where mean of the each of these is mu. So mean is mu, it means E of xi is mu. So you will get here mu square. Any doubt? Students, if there is any doubt, don't hesitate, because all the questions in the future will be of this type. Same kind of concept we have to use everywhere. So I can understand that you may not be getting this if you, so that is why I'm repeating whatever we have done. So students, we have a population in which the members are from the this x1, x2, xn is a sample. So we have taken some sample from here, x1, x2, xn, and because this population follow the normal distribution, this population follow the normal distribution with mean mu and variance 1. Okay, it means mean of everyone is mu and variance of everyone is 1. Okay, means mean of x1 is mu, mean of x2 is mu, mean of xn is mu, and variance of x1, x2, xn all have the variance 1. Okay, so that is why I have now I have used this, that variance is 1. Variance means e of xi square minus e of xi whole square. So this is equal to 1. Now send this e of xi whole square on this side. So you will get e of xi square is equal to 1 plus e of xi square. So now e of xi, the average of xi was mu, because every member of this population has mean mu. So that is why mean of x1, mean of x2, everybody have mean mu. So mean of e of xi will be mu. So you get mu square here. Okay. Now we are going to put this value of e of xi square in this equation number 1. So put in 1. So if we'll put this in 1, so we will get e of t is equal to 1 by n as it is, this 1 by n as it is, and e of xi square is 1 plus mu square. So 1 plus mu square, 1 plus mu square, you have n times summation. You will get 1 plus mu square plus 1 plus mu square plus 1 plus mu square n times. So n and n will be cancelled out, and you will get 1 plus, you will get 1 plus mu square. So you get that expectation of this t is equal to 1 plus mu square. It means this t is unbiased estimator of 1 plus mu square. This is what we have to show. Okay, so this is equal to right hand side. So to show that it was unbiased estimator, it means you have to show that the expectation of t is mu square plus 1. Okay. Any doubt? Any doubt, students? It means if you want to know mu square plus 1 in the population, we can use this one from the sample. Like, suppose I want to know the mean square plus 1, like you can say average blood platelets, and square of that plus 1 if I want to find out that. So what I can do is, so I can take a sample, and in the sample I can find these things. This sum of xi square divided by n. So that will give me an estimate for the unbiased estimate for the mu square plus 1. Okay. So there is some question in the public chat. E of xi is equal to u2 or mu E of xi is equal to mu. Oh, I think you want to ask this, right? Why E of xi is mu? So Roshan, this sample has been taken from this population. Okay, x1, x2, xn is a random sample from the normal population, where in this population everybody have mean mu and variance 1. Okay, so if everybody have mean mu and variance 1, x1, x2, xn also have mean mu and variance 1. So mean of x1 is mu, mean of x2 is mu. What is the meaning of mean? Mean means expected value. Expected value of x1 is mu. Expected value of x2 is mu, and so on. So that is why every member of the sample has mean mu, because population, in the whole population, if all having the mean mu, so this will also have mean mu. Every member of sample will also have mean mu. So this is a reason for it. Is it clear or still doubt is there? Should I try to explain more? Don't hesitate if it is not clear. Okay. Always ask the problems so that you get clarity about them. So students, take the 1 minute break and think about this question. Think about the definition of unbiasedness. Okay. So this parameter, this theta is not a fixed thing, students. This theta is not a fixed thing. Keep in mind. This can be like in the first example, this was mean. In the second example, it was mu square plus 1. Okay. Parameter, there are not one parameter, na. So many parameters are there for the population. You can measure anything of the population. So in the first example, they were asking, can we use a sample mean to measure the population mean? Is it unbiased or it is biased? So we have shown that it is unbiased because the expected value of sample mean is same as the population mean, so it is unbiased. In the second example, they asked us, can we use this T as unbiased estimator of mu square plus 1? So yes, I have shown that because expectation of T is same as this value mu square plus 1. So that is why it is unbiased. Simple. Okay. So just take 1 minute break and think about this unbiasedness. All students. So any doubt, students? Let me see any next example I have. We have the mm, first one to show you that this sample is not. Okay. But before that, let us do uh, one example. Okay. Mm, so this is a question. We also do try it together. Okay. This problem together. I would say this is on uh, screen. If x1, x2, and xn be random sample of size n from the normal population with mean mu and variance sigma square. Okay, students, again see the sample. Let me try to explain the diagram. So we normal population. The normal population has mean mu and the variance is sigma. Population have the same kind of characteristic. Now, if we take a random sample of size n, so we have taken some sample on x2 and xn. Okay, voice is breaking. Voice is breaking. Okay, let me use the second network. Just 1 minute, and I will try to connect with the second device. Okay, I think now network seems to be stable. Okay, let us see if there is any still problem in the further. Uh, then we can see. Okay, Roshan, now voice is fine. I think now it is clear. Roshan, okay. So we have to try this problem. Okay, uh, x1, x2, xn is a sample from the population where the population is from the normal distribution, and this population has mean mu and variance sigma square. It means every member of the population will have mean mu and variance sigma square. Okay, and we have to check the biasness of this t. So we t over mu square. So they are asking, can we use this? Can we use this to estimate mu square? Can we use this to estimate mu square? This is a query, or this is the problem that they have asked us. So can I use this t to estimate this unbiased? Okay. So if it is unbiased, in that case, the expectation of t should be equal to mu square. If you want to estimate mu square with this, then and you want to know whether it is unbiased or not. So in that case, the expectation of t should be equal to mu square. Let us find the expectation of t and check whether it is equal to mu square or not. Okay. So now I will find the expectation of t. What is t? So t is simple 1 by n sum of xi square, I varying from 1 to n. So now we will use the property of expectation. So the constant can come out of the expectation. In the unit 1, we have done these properties, students. Okay. So in the unit 1, we have done these properties. And first, one more thing I want to ask in between, by the way. Students, do you have the access to the lectures, recorded lectures that I am delivering here? Like, if you want to see lecture 1 again, so can you see that? If you cannot see that, then how you guys are? No. So Roshan answered no. You don't have the access of those recorded class, right? This is your answer, na? Okay, okay. Oh, okay. So I will see some solution for that. Okay. I will see some solution. Okay. Uh, no, no, it is actually automatically recorded here. Everything, whatever is going on. And see, I will see what we can do. Okay. So first, let us focus here. So we'll find expectation of this. So expectation of this 1 by n is constant. We can take outside of the expectation. Okay. So we can take outside of this. So 1 by n we can take outside, and then we can apply the property of expectation. We can bring this as, we can write this as I varying from 1 to n expectation of xi squared. Okay. So students, after this, what is the expectation of xi square? The same logic we have to use in the previous question, previous problem. So you can call this as equation number 1. Now you are given this sample has been taken from the normal population with mean mu and variance sigma square. So what is variance of each of the xi's? So variance of xi's is sigma square, right? So what is the formula for variance? One of the formula for variance is E of xi square minus E of xi whole square. This is equal to sigma square. So from here we can find the value of E of xi square. So E of xi square, this is equal to sigma square plus E of xi whole square. So which is equal to sigma square plus, now what is E of xi? E of xi means mean of xi. Now, because this population, every member has mean mu, so that is why xi will also have mean mu. So mu of mu square, right? So this is the E of xi square value. Now we will put this value in this equation number 1 and we will see what happens. So this was we are finding E of t, right? So E of t is equal to, so use in 1. So this step will be used in many questions, okay? This kind of thing. So use in 1, use in 1. If I use this in 1, so I will get E is equal to 1 by n as it is, and the sum of these. So if I put this sigma square plus mu square here, so I will get sigma square plus mu square, sigma square plus mu square, sigma square plus mu square n times. So that is n times sigma square plus mu square. So n cancel out. So we will get sigma square plus mu square. This is expectation of this estimator. So it is coming out to be equal to sigma square plus mu square, right? But students, you can see here, we want it equal to mu square. It means it is not equal to mu square, right? It is not equal to mu square. So therefore, it is not unbiased. So therefore, E of t is not equal to mu square because variance is never equal to 0. Means it is 0 if all things are same, but it is not never true in general about the population. Like it cannot happen that everyone is same. Okay, all data are same. It is not possible. So variance is never 0 in general real life. Okay, there is some variance always until it is a constant thing. Okay, so therefore E expected value of t is not equal to mu square. It means therefore t is not unbiased estimator of mu square. So this is what we have just shown. If any student have a doubt, then you can ask. Uh, we can say here that this T is unbiased estimator of sigma square plus mu square because its expected value is equal to sigma square plus mu square. So in the exam, this can also be asked. Show that T is, if we take the sample from normal population with mean mu and variance sigma square, then show that this T is biased estimator of mu square plus sigma square. So you have so same way you have to do. So till here you have to do. Okay. So now I will put the next question. The next is easy question, important from MCQ point of view. So let us see how many of you can answer this question. So currently my topic is unbiased estimator. So question is, if T is unbiased estimator of theta, show that T square is a biased. T is unbiased, then show that T square will be biased always. So we are given that T is unbiased estimator of theta. What is meaning of this first line? It means expected value of T is equal to theta. Meaning of unbiasedness. If T is unbiased estimator of some estimated theta, then expected value of T should be equal to theta. Now what we have to show? We have to show that T square is unbiased estimate of theta square. So it means we have to show that E of T square, this is not equal to theta square. We are saying biased. Biased means not equal. If there is unbiased, then it should be equal. So we have to show it. To show. Now, first of all, we need to think when this kind of thing comes. when E of t square comes into the picture. So you know what is variance of t? Variance of t is expectation of t square minus expectation of t whole square. Okay, like variance of x is expectation of x square minus expectation of x whole square. Now use this one. This is given. E of t is equal to theta. So put here theta. So you will get variance of t is equal to E of t square minus theta square. Because E of t is theta, because t is unbiased estimator of theta. Now, to send this theta square on other side, so you will get E of t square is equal to theta square plus variance of t. It means, therefore, E of t square is not equal to theta square. Why? Because variance of t is always greater than 0. Variance of t is not equal to 0. It is always greater than 0. So actually, if it is unbiased, then its expectation should be equal to theta square, but it is not equal to theta square. There is some other term also, right? So therefore, it is not unbiased. It is actually biased. Okay. So any doubt in this question? This is important from MCQ point of view. So I have seen, if you check the MCQ paper, or if you remember your exams, you must have seen this question there. Okay, in the MCQ portion. Any doubt? So I think if there is no doubt, we can move ahead. Okay, so next question is, sample variance is biased estimator of population variance. The question is, show that sample variance S square is biased estimator of population variance sigma square. Okay. So we are going to do this question now. Okay, so actually this is not the full statement. So let me write the full statement first, then we can do this question. The full statement is in this way. This is a 10 marks question. In normal distribution, n mu comma sigma here, show that the sample mean x bar is unbiased estimator of the population mean mu. So this we have done the first example which I have given to you, that if you find E of x bar, that will be equal to mu. Okay. In this normal distribution. But sample variance is a biased estimator of population variance sigma square. So I will be doing the second part. But S square is a biased estimator of population variance sigma square. So let us do it. Okay. So now I will show sample variance. Sample variance S square is biased estimator of population variance sigma square. So this is our aim now. Okay. So first of all, what is the meaning of sample variance? What is the meaning of sample variance? So for that we have to understand meaning of sample variance. What is the meaning of sample variance? So variance is average of square of deviation from the sample mean. So xi minus x bar is the deviation from the mean, and square of it, so square of deviations divided by total number of data points, that is called variance. Okay, from the data, if you want to find the variance, you can find in this way. Okay, like the formula, if there is a probabilities are involved, in that case, the formula is average of x minus uh, mu whole square. And there is one more formula also, which is E of x square minus E of x whole square. Means both are same. If you open this and apply the properties of expectation, you will get the second one. Okay. So these are the formulas, and for in case of probability. But here in normal data, the variance means average of square of deviation from the center or mean. Okay. Any doubt? Any doubt, students, in this? So now we will show that this is not unbiased. This is biased estimator of sigma square. It means we will show that E of S square is not equal to sigma square. This we will show. Okay. To show E of S square is not equal to sigma square. So students, there are two formulas for the sample variance. One is this one. Second is, so the first one is of this one. So uh, uh, average of deviation from the center, and second one is average of x square minus average of x whole square. So I will use the second one. Okay. So I will use the second one, that s square is equal to average of x square. So average means sum of xi square divided by total number of numbers minus average of x whole square, mean of x. Their mean of sample is x bar, so x bar square. I will use this one. Okay. This formula I will use for the variance. Both are same. If you simplify this formula, first one, you will get the second one. If we simplify the first one, we can obtain the second one. So any one you can use. Okay. Sample variance we can find in two different ways, as we can find variance in two different ways, right? Sample variance also we can find in two different ways. One is this one, other is this one. Both are same. Okay. The second one has been obtained from the first one. So for us, the second one will be easy to solve this question. So I will find expectation of S square. What is expectation of S square? What is S square? So expectation of 1 by n summation I varying from 1 to n of xi square minus x bar square. Apply the properties of expectation. The expectation of first minus expectation of second. Somebody have raised hand. Any doubt? Any doubt, students? Okay. So now I will apply the properties of expectation. 1 by n is constant. So 1 by n will come out. Summation I varying from 1 to n. Expectation of xi square minus expectation of x bar square. So now we have to find these values. Let us call this as equation number 2. So students, how we are finding E of xi square? So from the previous experience, you must be clear how we are finding E of xi square. So you know that the variance of xi. What is variance of xi? Because this sample has been taken from the normal distribution, where mean is mu and variance is sigma square. So variance of xi will also sigma square. Now what is formula for variance? Variance means E of xi square minus E of xi whole square. This is equal to sigma square. So E of xi square one side, keep it on one side, send other term on other side. So sigma square plus E of xi square. Now what is expectation of xi? What is mean of xi? So mean of xi, because the sample has been taken from normal distribution where mean of everyone is mu. So mean of xi will also mu. This will be equal to sigma square plus mu square. So this is the value of E of xi square. Okay, let us call this as equation number 3. So I have found this value of E of xi square. Same thing I have done in the previous three problems. Same thing I have done. Nothing changed. Okay. And now I will find what is the average value of x bar square. What is the average value of x bar square? So same way. So first, what is variance of x bar? What is variance of x bar? So anyone can anyone tell me in the comments what is variance of x bar? We have done this in the today's lecture.
Sigma upon root n.
Sorry.
So, sigma square upon n. Sorry, sigma square
Sigma
upon n.
square. Right. Very good. So we have done in the beginning that it is sigma square upon n. Let me show to others also. So the first step that I have done today. So variance of x bar, you can see here we have found it is sigma square upon n, right? So that is why I have done all these two things in the beginning because I understand this is going to be used in all these upcoming classes. That is why I have in the beginning I have done this, that variance of x bar is sigma square upon n. So that is I have written here variance of x bar is sigma square upon n. Now what is the formula for variance? So it is expectation of x bar square because I am finding variance of x bar minus expectation of x bar whole square. This is equal to sigma square by n. I want to find the value of E of x bar square. So this is equal to sigma square by n plus E of x bar square. You can see from here. Why I'm finding this? Because I need in this equation number 2. Okay. Now what is E of x bar? Yes, students. E of x bar we have found in the first thing that we have done today. First thing we have found in the today's class, E of x bar. What is that? So can you tell? E of x bar. I think I need to show you. No student is answering. You can see here. First thing we have done today, we have found E of x bar. So which was again mu. E of x bar is mu. So let us put here. So we got mu square. So this is equation number 4. So now we will use equation number 3 and equation number 4 in equation number 2. So we will get E of s square. This is equal. This is an important problem, student, from 10 marks point of view. Okay. So we are putting in the equation number 2. So 1 by n as it is. And then we have E of xi square, sum of this. So E of xi square is sigma square plus mu square. So because you have sum here n times, so it will be n times sigma square plus mu square minus E of x bar square. E of x bar square is this equation number 4, sigma square by n minus mu square. So this n cancel out. Sigma square plus mu square. Sorry, it was plus here. sigma square plus mu square, sigma square by n plus mu square. So this mu square and mu square will be cancelled out. We will get sigma square minus sigma square by n. So it is 1 minus 1 by n into sigma square. So students, expectation of S square is not coming out to be equal to sigma square. It is coming out to be equal to n minus 1 divided by n of sigma square. So therefore, this sample variance is not unbiased estimator of sigma square because it is not equal. Okay. So therefore, uh, expectation of S square is not equal to sigma square. So therefore, S square is not unbiased. It is biased. So S square is biased estimator of sigma square. So any doubt, students? So today's class is going to be over soon. So I think that this unit 5, uh, 3 topics are now there. Unbiasedness done. Then we have the meaning of consistent estimator and